Arithmetic sequences. A sequence is a list of numbers that follow a pattern. Each term of the sequence is noted by A sub n, where A sub 1 is the first term, A sub 2 is the second term, and so on. Our first example says write the first 5 terms in the sequence. So we'll start with n equals 1, and then I'll put a 1 everywhere I see an n. So that would be A sub 1 equals, so A sub 1 is the first term, negative 1 to the power of 1 plus 1 times 1 squared, which all equals 1. And then I'll fill a 2 in for n, then 3, then 4, all the way up to 5. A sub 2 would be negative 1 to the power of 2 plus 1 times 2 squared, which comes out to be negative 4. A sub 3, everywhere I see an n, I put a 3, times 3 squared, that comes out to be 9, and so on. So A sub 4 comes out to be negative 16, and A sub 5 is 25. So you just keep changing n from 1 all the way up to 5 and working it out each time. If the sequence is arithmetic, that means that the pattern is that the same number is continually added to get from one term to the next. For example, the sequence 3, 8, 13, 18, and so on forever, that's what those little dots mean, is arithmetic because 5 is added each time. The number that's added each time is called the common difference, and we call that D. So for this sequence, the 3, 8, 13, 18, the first term, A sub 1, is 3, and D, the common difference, is 5. Example, determine the common difference, the 5th term, the nth term, and the 100th term of the arithmetic sequence. So if you look at negative 6, 1, 8, 15, hopefully you can see that 7 is being added each time. So the common difference is 7. And then to find the 5th term, we would just add 7 to 15 because that's the 4th term. So A sub 5 would be 15 plus 7, which is 23. But if we kept on adding 7 to get to the 100th term, that would be very time consuming. But there's a formula for this. And so when they're talking about the nth term, they're talking about this formula. The nth term of an arithmetic sequence is A sub n equals A sub 1 plus n minus 1 times D. A sub n is the nth term, might be the 5th, the 100th, the 1000th, just whatever they ask for. A sub 1 is the first term, n is the number of terms, and D is the common difference. So to answer their question, the nth term for this particular sequence, A sub n would be the first term, which is negative 6, plus n minus 1, because they're not specifying, times the common difference of 7. Now we can use that formula to find the 100th term. A 100 would be the first term, which is negative 6, plus, in the parentheses, 100 minus 1, times the common difference, which is 7, and that comes out to be 687, much faster than continually adding 7 until you get to the 100th term. Now, if we want to add up some of the terms in the sequence, we have two formulas depending on what information we have. So you can see each formula. The second formula requires we have A sub n, which is the last term in the list of numbers added. Our first example says find the partial sum, S of n, of the arithmetic sequence that satisfies the given conditions. So we have A1, which is 4. We have D, which is 2. We have n, which is 20. We have everything we need to do the first formula. So let's fill that in. The sum of the first 20 terms would be 20 over 2 times 2 times A1, which is 4, plus n is 20 minus 1 times D, which is 2. and all of that comes out to be 460. This formula right here, we're going to use that because we have everything. We have the number of terms, we have the first and the last term. A partial sum of an arithmetic sequence is given. Find the sum. So we have some of the numbers, but these dots mean they're missing numbers in between that they didn't write out. And they want to know what all of the numbers from 1 to 401 all added together would come out to be. So let's see what we have already. We have the first term, which is 1. We have the last term, which is 401. And we can figure out the common difference. To get from one term to the next, they're adding 4 each time. But what we don't have is the number of terms. So we can't use either formula with what we've got there. But we do have a formula to find the number of terms if we use this formula that we used in an earlier example. Because we have all of the variables here except for n, and that's what we need. A sub n is 401, A1 is 1, we don't know how many terms, and D is 4. I can subtract 1 from both sides, then I have 400 equals n minus 1 times 4. Divide by 4, 100 equals n minus 1, and then add 1. So we know we have 101 terms. Now we can use the second formula. Let's go back to what. So S, the sum of the 101 terms would be 101 times 1 plus 401 over 2, and that comes out to be 20,301.